All right, so here's Calhoun.io, and he's putting out some nice articles. So take note of that and check out his articles. And you could get the first, you could get the first 2 chapters of his book, Calhoun.io. And he's doing a book on web dev with Go. Looks pretty good so far. Guy's got some nice credentials. Used to be a Google employee. Did some Silicon Valley startup stuff. Now it looks like he's living someplace beautiful with an old truck. So I think life's getting better for him. All right, so I wanted to show you a little bit about what we're going to be doing tonight. And let me just get a second to get that set up. So I did a training this weekend. If you go to YouTube Todd McLeod, or Todd McLeod, YouTube Todd McLeod, and go to playlists, and this might be annoying. This video kicks on automatically, but go to playlist quickly, you won't hear it. And an introduction to the Go programming language. And so, whatever, there's 35 videos in there. Just kind of an introduction to the Go programming language. And so we're going to be looking at servers tonight. And I've thought this through. I got sleep last night, and I have food in my belly, right? So I've got a game plan. I know, like last week at 9:30 or something, I just like completely crashed against the wall. So hopefully I'll be able to shed some light on that. But to understand that, we need to understand. One more thing I'll say about this training is that there are notes that correspond to that training, and so you could get to these notes by following that URL. So if you just want to screenshot that with your phone, you know, because phones take screenshots of this 3-dimensional world in which you live, which your eyes are always rendering. You could get to these notes, and so just take a moment and pull out your phone and do that. And I'll pause the video while you're doing that. I'll bring it right back up. Hold on, let me just pause this. So I just want to we're going to do a little bit of a review, and then we're also going to learn about interfaces, and then we're going to finish up with these challenges right here, because you need to know about interfaces before you can understand the web stuff and servers and what the HTTP.handler type is and how listen and serve works. And so you really need to understand interfaces, and then you have to understand handlers. So I put this into our notes right here, essentials, right? So to understand web dev with Go, you have to understand these core concepts. You have to understand what an interface is, and we haven't covered that. So that's part of the reason I hit a wall trying to explain to you last week, like, how can I explain this without you knowing this yet? So we got to figure that out. That will take us about a half hour. And then you have to know the entire request response pattern. And that's it. You know it. Because that's how the web works. Somebody makes a request, and then it gets fulfilled, and there's a response. And so that is part of the whole deal. And then there's some terminology disambiguation, which causes confusion. So we're going to look at all that. But the first piece is interfaces. And so to get to interfaces, I want us to do this challenge here. Both of them. But before we do those challenges, we're just going to review some stuff. And so first thing we're going to review are data structures. I'm just going to go to the Golang playground. We're going to do some banging away on data structures. Okay? And so the first 3 types of data structures. And let me just zoom this in. So let me see what happens when I do that. Well, that works pretty good. And we'll just see how well that keeps working. And so we could refresh our memory by going to golang.org, Golang spec. We'll just go straight to the specification. And we can look at the different types. And there's numeric types and string types and Boolean types. So those are like, you know, the basics. And then we have a map, and we have a struct, and we have a slice. Okay? So first one is a slice. Slice, map, struct. And so we've looked at all these. And so if I'm going to make a slice, there's a couple of ways I could do it. I could do like x : equals slice event, and I could do a composite literal. This is known as a composite literal. And more specifically or colloquially, you might just say it's a slice literal. So you could use either of those terms. Okay. And so a composite literal, if we look inside the spec, composite literal, a composite literal, and I think we saw this, construct values for structs, arrays, or slices and maps. Cool. And basically, you know, and it creates a new value each time they're evaluated. They consist of the type of the literal, followed by a brace-bound list of elements. Brace-bound, okay? And so that's what we have, the type, followed by a brace-bound list of elements. So a slice of ints, I could just put some ints in here. Okie dokie. And then I could print that. So when I run this, there it is. Cool. So that's creating a slice. One more way to create a slice. Y colon equals make a slice of int and give it that and this. And then I could do y equals append y7, y equals append y9. Actually, we'll do different numbers. We'll do 8, 12, 43. Hey, no problem. And unexpected semicolon or new line, expecting a paren. So I did this, and that shouldn't be there. So that's one more way we can make a slice. Those are the two ways I want you to use slices. Okay? So I'm going to pause this right here. I'm just going to copy that. And where am I going to put it? I guess where should I put that? Yeah, go ahead.
You did y as an integer, and then you gave it 0 and 100. So when you appended y with the 8, that overwrote the 0, and then the 12 overwrote the 100, and then 43 added it onto the end.
No, I'll show you what all that means in a second. So that's a really good question because I need to explain that. So keep me on task when you have questions. I'm just wondering where to put these notes. And I think I need to just create a new document. And so I'm going to go to my drive and go into school and go into, what is this, fall 2016 and CIT 90. And this is a new document. And it's week 5. And this is slices. And I'm just going to paste that URL there. And then I'm going to share this and advance anybody with the link. Link to share. Private. What the heck? Where's just like only share with others? Oh, that's what I want. Get shareable link. Anybody with that can view. There we go. And now I'm going to go put it on Blackboard. So you can get to that document by going to goo.gl/a capital O, capital 0, as if there were such a thing, capital O H6XW. So if you go there, you should be able to come to this document. And if you click that link, it should take you to this code. Okay? So let's go back to explain that code. So these are creating a slice. And we could create a slice with a composite literal like this, where we have the type and then braces and then the values. Or we could create a slice by using make. And we could say slice of it, give it the type, and then we could give it the length and the capacity. That's the length and the capacity. So slices are built on top of arrays in Go. We don't use arrays in Go normally for programming because arrays are a fixed size. Slices can grow. And so we want our slices to be able to grow. And
Todd,
yeah.
Sorry, I missed the bit that you were explaining about the 0 and the 100 because I was finding my link. Sorry.
That's okay. All right, so we can make a slice by giving a length and a capacity. The length, slices in Go are built on top of arrays. All right, and when we build a slice, it's on top of an array. This sets the size of the array. This sets the size of the slice of the spots that are being used. So let me just demonstrate, okay, what's going on with that. So I make 0, and if I do this, format print line length of y, and then also format print line cap of y, and let me just put these in here so you can see it. Length, y, capacity, too many arguments. What did I do wrong? Format print line, length of y. Okay, that needs to be out here. Length is 0, capacity is 100. That's what I set. Length is 0, capacity is 100. And so now, if I add something to y, and run these again, length 0, capacity 0. Length 1, capacity 100, because I've added 1 in there. So what is in my slice? Right now, nothing's in my slice, right? And then I add something in, and then my slice, the length becomes 1. Okay? And you want to, it's good to make your slice this way for performance reasons. Here, if I have 2, right? Cool. And then watch what happens as I make more stuff. Try to use my editor commands in here sometimes. Let me do it this way, actually. Whatever. So here's what happened. First, this is my length and capacity. I add 1 in, my length and capacity become that. I append another one, my length and capacity become that. I append another one, my length and capacity become that. So capacity had to double. So created array originally of size 2, so it could hold 2 items, right? But then when it got full and I tried to add a 3rd item, it had to throw away that old, copy the values from that old array into a new array, throw away the old array, right? And that new array, it doubled the size of it. Okay, and that's a performance cost because you have to have this processing to do all that. So you might know, hey, I'm going to have to stick 100 records into this thing. I'm just going to make sure the underlying array is at least the size 100. Why would you not just do like this? Let's try this, see what happens. Length 50, length 51. So it started, right, like...
Oh, it started at 50.
Yeah, it's already got like 50 things in there, right? So if I wanted to now, I could say like, I could do like y. Let me just think about this for a second. I could do so I could do format print line. See if that does it. All right, at position 51, all right, index position 51, I have 15. So put it at 50, right? Because this is actually 0 base. It gets a little bit confusing. The takeaway is there's two ways to create a slice. Okay? This way, slice int, composite literal, and this way with make. So that's the takeaway. And when you do this, if you do make 0, length 0, and let's just do like 10, and let's just play with this for a minute. And I wanted to do y is equal to append, and append to y 777, there we go. So appending to y, and then format.println. Let's just play with this for a second. This might be a better way to explain it. So I've got one value in my slice event. And I guess I'll show the next thing here. So for index value colon equals range y lets me loop over a slice or a map or those kinds of data structures. And I'm going to do format.println I v, and in between a dash. So at index position 0, I have 777. So this is how I'd range over a whole bunch of values in a slice. Like if I applied this up here, range over x, and I'm just going to get rid of this one. So when I range over x, 0, 1, 2, right? Index position 0, I have 7. Index position 1, I have 9. Index position 2, I have 42. And I could print things by their index position if I wanted. I could have also said, hey, x position I. And give me the same results. V is declared and not used. I'm going to throw that away. That's the blank identifier. So if you're going to have a variable, you have to use it. If you know something's assigned, you don't need it, you could throw it away like that. I think with this, you could even do that. And it just gives you your index. But I just always think IV, index value, for ranging over a slice. So format println I, xi, because this at, this slice event at this position, accessing by position, it gives me the value at that position. Or I could just do V. So I'm going to leave it this way so you can see that. And also down here is the V way, and I'm going to share this and copy that. And I'm going to put it in here and slices, and I'm going to add here. This would be for range loop and index position. So we can make a slice of int with a composite literal or a slice literal. We can make a slice of int with make, give it the length and the capacity. So here we just appended. What if I had, like I start out with a length of 5 on my slice, and then I append. Let's see what happens. At index position 1, 0, 2, 0, 3, 0, 4, 0, right? That is 1, 2, 3, 4, 5, right? Those are 5 things. I said my length is already 5. And now at this position, when I append, and this is the 6th position in the slice because it's 0 base indexed. Let me just comment this one out for now, or we'll just get rid of that one. But then x isn't being used, and it's not going to like that. But here we'll do it like this. Just get rid of it for a sec. So we're not paying attention to that. All right? So when I append, if I've used a length there, then those all got initialized to 0. which is cool because I could say y0 is equal to 17. Now, if I didn't have anything there, like at 0, right? When I have 0, let me put this up here. Format. There we go. Let's just make this like, hey, y4. It's at 0, 1, 2, 3, 4, the fifth position. Run it. Index out of range. Because I'm trying to access something here, and that's not there. But if this was 5, because, oh, cool, I have that position. It's been initialized. I've set it to 0. All right, so now I could use this to assign to it. I could say, hey, at that position, put this here. But if that position doesn't exist yet, my length is 0 in my slice. There's nothing in there. Not even the slot set to 0. It doesn't exist yet. Hasn't been initialized. I run that, panic, out of air. But if this one is 5, then that position exists, right? But if I'm just going to be appending stuff, then, you know, I just want that to be 0 because as I append, it's just going to, okay, there's nothing in there and I'm appending. Now there's 1 in there. Hopefully that clicked it a little bit. So the main thing to take away is that we make slices with that, and that's called a composite literal. Or you might also refer to it, since it's a slice, as a slice literal. But the catch-all phrase for all of the composite literals we're going to be learning is composite literal. And that's how we make a slice, right there. Composite literal. Or you can make a slice with make. So y : equals make, slice of int, length of 0, and the underlying array size is 10. And so that will be helpful, like one of our examples in our code, which we didn't look at, which was, where was that, Patrick? The one where it's like parsing the CSV, here it is, right? We parse this CSV file, and we say, hey, let's make a slice of records. Okay, we're going to make a slice of record, and a record just has this information. And we're going to store that in a slice. And the initial size, the length of that slice is 0, and the length of the underlying array is going to be however much data we have. So it's automatically making that underlying array the right size. We won't have to destroy, copy, recreate into a new array. And yeah, so that's how you would use make. And so then, but I always need to append, because there's no spots already initialized to 0, right? If I wanted to then just go in and assign things to different spots using that index access, I would need to like set this number here so it initializes them to 0. All right. Anybody have questions about that?
What is 10 again?
What is 10 right here? That's the capacity. So that's the size of the underlying array.
But if you create more slices in the array, that will automatically adjust, yeah?
More entries in the slice, you mean?
Yeah, more entries in the slice.
Yeah, it'll automatically change the size of the underlying array if you exceed the capacity.
But that would be a performance issue because then it has to go through that.
Yeah, and when we talk about Go performance issues, they're not, you know, I mean, Go performance issues are like optimized code in other languages, but good to know about the nuances. Cool? Do you all feel like you need to practice that, or you can practice that on your own? So let's make some headway, right? You got it? So you guys just communicate with me. If you're like, I need to practice it, practice it. Let's practice it. Okay, we'll practice it. Huh? Yeah, but also, like, you could do this practice at home.
Oh, yeah.
Yeah, right? Okay, because there's going to be more stuff coming. All right, so let's save the practicing for till we get through a couple.